Hi, in this video I'll be explaining linear programming problem using Simplex method. Here we have a maximization problem which says solve the following linear programming problem using Simplex method. Maximize z equal to 3x plus 1 plus 2x2 subject to x1 plus x2 less than or equal to 4, 2x1 plus x2 less than or equal to 5, x1 plus 3x2 less than or equal to 9, where x1 and x2 is greater than or equal to 0. To solve this problem, we need to consider the constraints. From here, we have 3 constraints. And secondly, you consider the type of inequality you have. Here we have less than. That means we are going to add our slack variable. Assuming it was greater than, you will subtract your surplus variable. So here we have our solution. Since this is less than, we need to add the slack variable. We have the question which says z equal to 3x1 plus 2x2. So this is our objective function given to us, and our constraints, as I said, we have 3 constraints, and this is the objective function. So we are going to add the slack variable now in our constraints. Therefore we have x1 plus x2. Here we add plus x1 equal to 4. This is for first constraint. The second constraint, which is 2x1 plus x2 plus s2, which is our slack variable, equal to 5. And the third constraint, which is x1 plus 3s2 plus s3, the third slack variable, equal to 9. The next thing to do is to add this slack variable to your objective function. So here we have plus 0x1 plus 0x2 plus 0x3, where x1, x2, x1, s2 and s3 is greater than or equal to 0. So the next step is to form our table. This is our table, where Cj is the coefficient of the objective function, Cb is the coefficient of the basic variable, and Bv is the basic variable. And we have Zj. Remember, I said Cj is the coefficient of our objective function, and from the question given to us, this is our objective function, and the coefficient of the objective function, we have 3, 2, 0, 0, 0. So we're going to represent it on the table. 3, 2, 0, 0, 0. So we have 3, 2, 0, 0, 0. For the basic variables, we have x1, x2, x1, x2, and s3. So we have x1 here on the 3, which is x1, 2x2. We have x2 here, x1, 0x1, 0x1, 0x2, we have 0x2, 0x3, we have 0x3. We have our solution here, also called B, and also we have our ratio. The values that will be here will be our constraints, which I will show you from constraint 1. This is constraints 1, 2, 3. For the first constraint, we have x1, x2, s1 equal to 4. Remember, here we have the coefficient of 1. Here 1. Here is also 1. So we are going to represent that 1, which is under x1, 1, 1. There is no x2 here, so we represent that with 0. We have 0, no x3 for constraint 1. We also represent that with 0. For the second constraint, we have 2x1 with the coefficient of 2, x2 with the coefficient of 1, x2 with the coefficient of 1. So we have 2, x2 with the coefficient of 1. We don't have any x1, write 0. x2 is 1, 1. There's no x3 for constraint 2, so represent that with 0. So for the third constraint, we have x1 with 1 coefficient, x2 with 3 coefficients. So we have 1 here, we have 3. There's no x1, there's no x2, so we add 0. 0, 0. x3, we have 1 coefficient, we write 1. For the solution, we have 4, 5, 9. Represent that on the solution here. 4, 5, and 9. The next is to write our basic variable here for the column. The slack variable also helps us to form our identity matrix. So here I'm going to tell you what I mean by identity matrix. So with the identity matrix, you know what your basic variables are. So this is our identity matrix. This is with 2 columns and 2 rows. We have 1, 0, 0, 1. Identity matrix for 3 columns and 3 rows. We have 1, 0, 0, 0, 1, 0, 0, 0, 1. Identity matrix with 4 rows and 4 columns. We have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. If you want to go ahead to find the one with 5 columns and 5 rows, we have 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 0, 1. So this forms your identity matrix. It could be 2 columns, 2 rows, 3 columns, 3 rows, 4 columns, 4 rows. But here we have 3 columns and 3 rows. So from here, from this our table, we have 3 columns and 3 rows. So can you guess what forms the identity matrix? Look at x1, x2, x3 forms our identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have x1, x2, and x3 because this forms our identity matrix, as I said, 1, 0, 0, 0, 1, 0, 0, 0, 1. So we need to find the coefficients of x1, x2, and x3. So from the objective function, the coefficient of x1 is 0, x2 is 0, x3 is 0. So we represent it here, 0, 0, and 0. The next is to find our value of zj, and to find zj, we have formula for that. Zj equal to cb inverse of b aj. So I'm going to show you how to find zj from our table. So to find your cj, here is our cb. We have 0 times 1, 0, 0 times 2, 0, 0 times 1, 0. We sum everything here. 0 plus 0 plus 0. We have 0. For the second table, which is x2, we have 0 times 1, 0, 0 times 1, 0, 0 times 3, 0. When we sum 0 plus 0 plus 0, we have 0. For x1 here, 0 times 1, 0, 0 times 0, 0, 0 times 0. 0. We sum everything, we have 0. For x2, 0 times 0, 0, 0 times 1, 0, 0 times 0, 0. We sum everything, we have 0. For x3, 0 times 0, 0, 0 times 0, 0, 0 times 1, 0. So we sum everything, we still have 0. So the next, we can also do for b here. I'll tell you why it's necessary to do for b. 0 times 4, 0, 0 times 5, 0, 0 times 9, 0. When we sum everything, we have 0. Let's say our z here is 0. So the next is to find your reduced cos. To find your reduced cos, the formula is cj minus zj. You can also use zj minus cj. I'll explain. This is the formula to find our reduced cost. Cj minus zj less than or equal to 0. Or if you are using this formula, zj minus cj greater than or equal to 0. So for us to reach optimality, because I'm using this formula, for me to reach optimality, all my values in that reduced cost must be 0 or less than 0, because this is less than 0. Anything less than 0 tends to negative, like 0, minus 1, minus 2, minus 3. While if you're using this formula to reach your optimality, it must be greater than or equal to 0, meaning everything tends to the positive, which is 0, 1, 2, 3, 4, 5. Since I'm using this formula, for me to reach optimality, all my values must be 0 or less than 0. I'm going to explain that. Since this is a maximization problem and I'm using this formula, so for me to reach optimality, all the values here must be 0 or less than 0. Formula to find the reduced cost, cj minus zj. We have, this is our cj and this is our zj. 3 minus 0 is 3. 2 minus 0 we have 2. 0 minus 0 we have 0. 0 minus 0 we have 0. 0 minus 0 we have 0. So you see here we have positive values. So we need to find the key column. To find the key column here, we need to find the highest number, which is 3. So x1 forms our key column. This is our key column here. So when you get your key column, you get your ratio. So the key column helps you to get your ratio. And to get the ratio is 4 all over key column. That's 4 over 1. We have 4 over 1 here equals to 4. 5 all over 2 here. We have 9 over 1, which is 9. So the next is to find our key row or pivot row. So to find our key row, we need to get the least value. So between 4, 5 over 2, and 9, what is our least value here? Our least value is 5 all over 2, because 5 all over 2 will give us 2 whole number 1 over 2. So this is the least value. So this is our key row or pivot row. So after getting your pivot row, you find your key elements or your pivots. So 2 is our pivot or key elements, because this is where these two lines join. So 2 is our pivot or key elements. After getting your pivot or key elements, it helps you to know your leaving variable and entering variable. So from here, we could see that the row is in x2. So x2 here is our leaving variable. Meanwhile, x1 here is our entering variable. So we are going to form another table. So this is our first iteration. So we are going to represent our objective function here. In our formal table, we have 3, 2, 0, 0, 0, 0. So we're going to represent this on a new table here. We have 3, 2, 0, 0, 0 with our solution and also ratio. Our BV, we have x1, x2, so nothing changed. We will still represent that on the new table. We have x1, x2, x1, s2, s3. So for our basic variable here, we have from the old table, we have x1. So we have x1 here. Remember, this is our leaving variable x2 and this is our entry variable. So we represent this here. So we have x1 and we have x3. We have x3 here. After this, we find the coefficient of x1, x1 and s3. The coefficient of x1 here is 0. We have 0. For this x1, we have 3. We write 3. For x3 here, we have 0. We write 0. The next thing to do is from our old table here, remember this is our key elements or pivots. So we're going to reduce this to 1. That's our pivot or key element. And to reduce this to 1, it will divide by itself. And it applies to every other thing in this row. We have 2 all over 2, which is 1. Here we have 1. 1 all over 2. We have 1 all over 2. For x1 here, we have 0. 0 over 2 is 0. We have 0. For x2 here, 1 over 2. We have 1 over 2. For x3 here, we have 0 over 2, which is 0. For x3, we have 0. For b, which is our solution, we have 5 all over 2. We have 5 over 2. The next thing is to find our new values. So I'm going to tell you the trick on how you can find your new values. Remember, here is our key elements or pivots. So to find the new values of what is going to be here or here, first of all, we are going to write these out, and also we are going to consider the old x1. This is the old table here. We are going to consider all these values, which will help us to get the new value. Same thing with x3. I'm going to explain what I'm saying. Okay, I've written them out. So this is our x1 and this is our x1. So we want to find the new values for this. Remember, for x1 we have 1, half, 0, 1, 5 over 2. So the same thing here, we have 1, half, 0, 5 over 2. And our old table, which is x1, we have 1, 1, 1, 0, 0, and 4. So the same thing, we have 1, 1, 1, 0, 0, and 4. Remember, this is our key elements or our pivots. So the trick to get our new value is to multiply the pivots or our key elements with the adjacent value, but we have to multiply it with the opposite sign of the adjacent value. So we have 1 as the adjacent value here. So the essence of this is to get 0, because the numbers in our key elements above or below, like here, here, or here, should be 0. So we want to get 0. So for us to get 0, we need to multiply this times minus 1. That is the adjacent value, but with the opposite sign, so that the combination of these two will produce 0. 1 times minus 1 is minus 1. 1 minus 1 gives us 0. So these are our pivots, act as a focal point. So everything in the new table is calculated with respect to this number. So this acts as our focal point, as our map, direction. So multiplying this with the adjacent value of this, which the opposite sign of the adjacent value, gives us 0. Applies to other values here. So we'll multiply this with minus 1 times minus 1 times minus 1 times minus 1 times minus 1. I'm going to show another example for you to understand. This is another example. Let's say our pivot is here. Pivot is always 1. So let's assume this is our key element and we want to find the new value. So to get the new value here, we need to multiply this 1 with the adjacent value, which is 3, but with the opposite sign. So the opposite sign of this will give us 3, right? We multiply times 3. Essence of this, so that the combination of these two things produce 0. So 3 times 1 will give us 3. Minus 3 plus 3 will give us 0. And this applies to other numbers here in order to get your new value. So back to our question here. So we have 0 here. Our new value for x1 is 0. We write 0. For s2, for the second one, 1 over 2 times minus 1 will give us minus half. 1 minus half will give us half. So we have half here. For x1 here, 0 times minus 1 will give us 0. 1 plus 0 will give us 1. So we have 1 here. For x2, 1 over 2 times minus 1 will give us minus 1 over 2. 0 minus 1 over 2 will give us minus 1 over 2. So we'll say here minus 1 over 2. For x3 here, 0 times minus 1 is 0. 0 plus 0, we have 0. So we have 0 here. For B, 5 over 2 minus 1, we have minus 5 over 2. So 4 plus minus 5 over 2, we have 3 all over 2. So here we have 3 over 2. We do for S3 also. For S3 here, we are still going to write everything here in our key row and consider our old values in our old table, which is 13001. So we are going to write them out in order to find the new value that should be here. I've written them out. For our key row here, remember we have 1 half 0 half 0 5 over 2, 1 half 0 half 0 5 over 2. And for x3 from our old table we have 130019, 130019. To find our new value, remember here is our key elements or our pivots. To get our new value, we are going to multiply this, our pivot or key element, with the adjacent number, but with the opposite sign. So the adjacent number here is 1, and the opposite sign of plus 1 here is minus 1. So we'll multiply this with minus 1, and the same thing applies to this, minus 1 times minus 1 times minus 1 times minus 1. So that minus 1 times minus 1 is minus 1. Minus 1 plus 1 is 0. So the essence is to get 0. I told you this is our focal point. This is just like a map, direction. We have 0 here. 1 over 2 times minus 1 is minus 1 over 2. Minus 1 over 2 here plus 3 will give us 5 all over 2. We have 5 over 2. For the second one, 0 times minus 1 is 0. 0 plus 0 is 0. Here, 1 over 2 times minus 1, we have minus 1 over 2 plus 0 minus 1 over 2. So 0 times minus 1 is 0. 0 plus 1, we have 1. 5 over 2 times minus 1, we have minus 5 over 2. Minus 5 over 2 plus 9, we have 13 over 2. So we'll write this in our new table. The new value for x3, we have 0. We have 0 here. The next one is 5 over 2. We have 5 over 2. Next one is 0. We have 0. The next one is minus 1 over 2 and 1. Minus 1 over 2 and 1. The next one is 13 over 2. We have 13 over 2. The next thing is to find our zj. To find our zj, remember I said the formula for the zj is cb times b minus 1 aj. To find our zj, we have 0 times 0, 0. 3 times 1, remember this is 1, 3. 0 times 0, 0. So 0 plus 3 plus 0, we have 3. We have 0 times 1 over 2, 0. 3 times 1 over 2, we have 3 over 2. 0 times 5 over 2, we have 0. 0 plus 3 over 2 plus 0, we have 3 over 2. For this one, 0 times 1, we have 0. 3 times 0, we have 0. 0 times 0, we have 0. 0 plus 0 plus 0, we have 0. For here, 0 times half, we have 0. 3 times 1 over 2, we have 3 over 2. 0 times minus 1 over 2, we have 0. So when we sum everything, we have 3 all over 2. For this one here, x3, we have 0 times 0, 0, 3 times 0, 0, 0 times 1, 0. So when we sum everything here, we have 0. 0 times this, 3 over 2 is 0. 3 times 5 over 2, we have 15 over 2. 0 times 13 over 2, we have 0. So we'll sum everything, we have 15 all over 2. So the next is to find our radius cost. To find our radius cost, we have cj minus zj. And cj, we have 3 here. That's 3 minus 3, we have 0. 2 minus 3 over 2, we have 1 over 2 here. 0 minus 0, we have 0. 0 minus 3 over 2, we have minus 3 over 2. 0 minus 0 here, we have 0. Remember, this is the value for our z, equal to 15 all over 2. Or we can say z equal to 15 all over 2 here. From here, we've not still arrived at the optimal solution because we still have positive number here. The next is to find our key column. or our pivot column. So to find our key column, we take the highest number, which is half. So here is our key column, and from the key column you get your ratio. So to get your ratio, we have solution all over 1 over 2, which is your key column. So 3 over 2 divide 1 over 2. We have 3 all over 2 all over 1 over 2. We have 3 here. 5 over 2 all over 1 over 2. We have 5 here. 13 all over 2 all over 5 over 2. So we have here 13 over 5 here, which is the same thing as 2.6. The next is to find our key row or our pivot row. So remember, to find your key row, we take the least value, and from between 3, 5, 2.6, the least value here is 2.6. Here is our key row or pivot row, which is x3. So from our pivot row, we'll find our key elements or pivots, which is 5 all over 2, because this is where the key column and the key row, this is where they join. So our pivot here is 5 over 2 or key element. So the next thing is to find the second iteration, because this is our first iteration here. So we're going to form another table. Remember, this is our key elements or pivots. So meaning from here, S3 is our leaving variable and S2 here is our entering variable. S3 is leaving and S2 is entering. And also, why I like to find the values of Z here is to check if I'm on track. So to check if you're on point, you can verify if this is correct. How do we do that? We verify that by, from the objective function given to us, now we want to verify this if we are on point, if there is any mistake somewhere. So from here, our X transpose, which is XT, is equal to, so we look at the values on this column, which is our solution column. Here we have X1 to be 3 over 2, X1 here to be 5 over 2, and X3 here to be 13 over 2. So our X transpose here, the value for X1 is 5 over 2. So we write 5 all over 2. Our value for X, there is no X2 here. We'll write 0. For X1, we have 3 over 2. We have 3 over 2. And for X2, there is no value for X2. We write 0. For S3, look at it, we have 13 all over 2. Remember, we are considering this B. We want to check if we're on track. So X3 is 13 over 2. We have 13 over 2. So to check if we're on track, we'll consider the objective function. Remember, this is X1, X2, X1, X2, and X3. So we consider the objective function here, 3, 2, 0, 0, 0. So from here, we have X1 to be 3. Remember, we'll say 3 times 5 all over 2 plus X2, we have 0. 2 times 0. We say 2 times 0. For X1 we have 0. So plus 0 times 3 over 2. Remember, X2 and X3 have 0. So we say plus 0 times 0 plus 0 times 13 all over 2. So to check if you're on track, we need to sum this. 3 times 5 is 15. We have 15 over 2. 2 times 0 is 0. Everything here is 0. 0 times this is 0. 0 times this is 0. 0 times this is 0. So we have 15 all over 2. So we're on track. So if you arrive the same answer with this, you know that you're on track. So we can move over to the next table. So this is our second iteration. We have 3, 2, 0, 0, 0. So we're going to represent it 3, 2, 0, 0, 0. We have solution. We have ratio here. For our basic variable here, we have X1. So represents x1. We have x1 too. We have x1. Remember, x3 is the living variable and our entry variable is x2. So here we're going to write x2. So we have x2. The next thing to do is to divide all these values with our key elements. Remember, we have 5/2. So we want to obtain 1 here. For us to obtain 1 here, we need to divide everything with 5/2. 5/2 divide 5/2 will give you 1. So we divide everything here. 5/2. 0 divided by 5/2 will give us 0. This will give us 0. 5/2 over 5/2 we have 1. 0 divide 5/2 we have 0. Minus 1/2 divide 5/2 we have minus 1/5. 1 divide 5/2 we have 2/5. For this, 13/2 divide 5/2 we have 13/5 for this. So we have 13/5. So the next thing to do is to get our new values here for x1 and x1. So remember, our key element or pivot is 1. We are going to write this out as usual. Let's do for x1 this. So we are going to write the old table from our first iteration we did. We are going to write the values here. We are going to write them out for x1. This is the number. I've written them out. We have 1, 1/2, 0, 1/2, 0, and 5/2. For x1, from x1 we have 1, 1/2, 0, 1/2, 0, 5/2, which is the same thing. For x2 here, remember this is our key elements, which is from here. We have 0, 1, 0, minus 1/2, 2/5, and 13/2. Remember, as I always say, this is our focal point. So this is just like our map. And the trick here is to multiply our key elements, which is 1, with the adjacent value, the opposite sign of the adjacent value. And the adjacent value here is 1/2. So to multiply this one, we need to multiply it by minus 1/2. So that the combination of these two things produces 0. And the same thing applies to other value. We'll multiply with minus 1/2. Minus 1/2 times minus 1/2 times minus 1/2. This acts as our focal point. Minus 1/2 times 1 will give us minus 1/2. Minus 1/2 plus 1/2 will give us 0. So let's do for this. Minus 1/2 times 0 is 0. 0 plus 1 is 1. So for our new value for x1, we have 1 and 0. The same thing here. Our new value for x1, remember here, we got 1. So we write 1. The second one is 0. We will write 0. So we do for others as well. Minus 1/2 times 0 is 0. 0 plus 0 is 0. We write 0. We come here, write 0. For this, minus 1/2 times minus 1/5, we have plus 1/10. So 1/10 plus 1/2 will give us 3/5. We have 3/5 here. So for this row, we have minus 1/2 times 2/5 will give us minus 2/10. 0 minus 2/10 will give us minus 2/10. Minus 2/10 is 1/5. The same thing applies to this. 13/5 times minus 1/2 will give us minus 13/10. So minus 13/10 plus 5/2 will give us 6/5. So here we have 6/5. We are going to do that for x1 as well. So we're going to write out all the values here in our pivot row or key row. I will consider the values from our first iteration for x1, which is this. We are going to write out the values here. So these two values will help us to get the new value that should be here. I've written the values out. For our pivot row or key row, we have 0, 1, 0, minus half, 2/5, and 13/5. Remember, this is our pivots or key elements, which is this. And for x1, this value, we have them here. 0, half, 1, minus 1/2, 0, 3/2, 0, half, 1, minus 1 over 2, 0, 3 over 2. So to find our new value now, this is our focal point. The trick here is to multiply this one, this is our key element or pivot, with the adjacent value, the opposite sign of the adjacent value. So here we have 1 over 2, so we are going to multiply this minus 1 over 2. The essence of this is 2, so that when we combine these two, we'll get 0. The same thing applies to other values. We multiply times minus 1 over 2. So this acts as our focal point, times minus 1 over 2. So with this, with the help of this, you get your new value, times minus 1 over 2, times minus 1 over 2. So 0 times 1 minus half is 0. 0 plus 0 will give us 0. 0 times this is 0. When we add 1 plus 0 will give us 1. Minus 1 over 5 times minus 1 over 2 will give us 1 over 10. So 1 over 10 minus 1 over 2. It will give us minus 2 over 5. 2 over 5 times minus 1 over 2 will give us minus 2 all over 10. So 0 minus 2 all over 10 will give us minus 2 over 10, which is minus 1 over 5. 13 all over 5 times minus 1 over 2 will give us minus 13 all over 10. Minus 13 over 10 plus 3 over 2 will give us 1 over 5. So this is our new value. We have 0 here. We'll write 0. We have 0, 0. We have 1, 1, minus 1, minus 2 over 5, minus 2 over. Please be careful. Make sure you're writing them under the variables. Like x2 here, we have minus 2 over 5. x2, we have minus 2 over 5. For x3 here, we have minus 1 over 5. We have minus 1 over 5. For b here, we have 1 over 5. So for b, we have 1 over 5. So the next thing to do is to get our value for cb. So for x1 here, we have 0, right? For x1, we have 3. For x2, we have 2. So the next is to get our zj. So to get our zj, 0 times 0, 0, 3 times 1, 3, 2 times 0, 0, 0 plus 3 plus 0, we have 3. For this one, 0 times 0, 0, 3 times 0, 0, 2 times 1, 2, 0 plus 0 plus 2, we have 2. 0 times 1, 0, 0 times these 0s, 2 times 0, 0, we have, when we combine them, we'll have 0. 0 times minus 2 over 5, we have 0. 3 times 3 over 5, we have 9 over 5. 2 times minus 1 over 5, we have minus 1 over 10. So when we combine these two, we have 7 over 5. For these, 0 times this, we have minus 0. 3 times minus 1 over 5, we have minus 3 over 5. 2 times 2 over 5, we have 4 over 5. When we combine these two, we have 1 over 5. The same thing with this. 0 times this is 0. 3 times 6 over 5 is 18 over 5. 2 times 13 over 5 is 26 over 5. When we combine these two, we have 44 over 5. So this is just like the value of our z. 44 over 5. So the next thing is to find our reduced cos, cj minus zj. This is our cj here. We say 3 minus 3 is 0. 2 minus 2 is 0. 0 minus 0, we have 0. 0 minus 7 over 5, we have minus 7 over 5. 0 minus 1 over 5, we have minus 1 over 5. We've reached our optimal solution because all the values here, they are 0 and they are less than 0. Since we've reached our optimal solution now, we are going to confirm if this is correct. We have our x transpose to be this value. All the value in our solution is your transpose. To get our x transpose, we observe that the x1 value here is 1 over 5. This value here is 6 over 5. So we are considering all the numbers in our solution column. In x2, we have 13 over 5. So we want to confirm if this value will give us this optimal value here. We're going to write the values out. So for x1, we have x1 to be 6 over 5. We write 6 all over 5. For x2, the value for x2 here is 13 over 5. 13 over 5. So for x1 is 1 over 5. Write 1 over 5. For x2, there is no value for x2 and x3. So we'll write 0. We'll write 0 here for x2, 0 for x3. So this will help us to calculate the optimal value for z. So to find the optimal value for c, remember from our objective function here, we have 3 to 0, 0, 0. We have 3x1, 2x2, 0x1, 0x2, and 0x3. So we are going to substitute this number into these values, or you can as well use this from what is given to us. It's still the same thing. 3x1, 2x2 is still the same thing. We are going to substitute our x transpose, all the values we got in our s transpose here. So we have 3x1, which is 3 times 6 all over 5. 6 over 5 plus, for x2 we have 2, so 2 times 13 over 5. 2 times 13 all over 5 plus, for x1 we have 0, x2 we have 0, x3 we have 0. So we say 0 times 1 over 5 plus 0 times 0 plus 0 times 0, which is this 2. Therefore, 3 times 6 is 18. We have 18 all over 5 plus 26 all over 5 plus 0, 0, 0, 0. So from here, we're going to sum these values together. And when we sum the values together, we will have 18 plus 26. We have 44 all over 5, which is the same with what we got in our table here. So this helps us to get our maximum value for z. So this is a maximization problem. Our maximum value is 44 all over 5. Right now, we've come to the end of this lesson. So if this video interests you, why don't you like the video, subscribe, and also put your comments, and I will see you in my next lesson.